After finding the value of b sub 0 and b sub 1, we can then calculate what is called coefficient of determination, and the notation for that is r squared. And coefficient of determination measures the goodness of fit between the straight line b sub 0 plus b sub 1 x and the sample points themselves. Before we develop a formula for r squared, let's look at what the error values are. So initially, when you look at only the value of y, the sales in our pizza example, and don't consider the x at all, then you have a bunch of y values, and we can compute the average of the y's. Okay, so here is the average y bar, and each point has some error with respect to y bar. So y minus y bar is the total error when y is taken by itself. And we can square this and sum this, and we will have what is called SST, total sum of squares. Now when you bring in x into the equation and you fit the straight line, then what happens is that now we can estimate y more closely using the b sub 0 plus b sub 1 x line, and we get y hat here. The error now is only y minus y hat. So the original total error of y minus y bar, this amount, y hat minus y bar, is no longer an error. So if you take that part and square it and add it, that gives us what is called sum of squares of regression, which is the amount of error that is in total sum of squares, which is no longer an error. So what remains the balance, y minus y hat, that is our new error. So if you square that and sum that, you get SSE, sum of squares of error. Now, of course, SST is equal to the sum of these two sum of squares, SSR and SSE. Since these are sums of squares, we can assemble them in a table, and we call this table ANOVA table, but this is a different kind of ANOVA table from chapter 13. This is the ANOVA table for regression analysis. So you have regression sum of squares, and the degrees of freedom is 1. Then you have error sum of squares, SSE, degrees of freedom is n minus 2. You add these two, you get SST. You add these two, you get n minus 1. Then you divide the degrees of freedom into the sum of squares. You get the mean square. And of course, then you divide MSE into MSR, you get an F statistic. We'll talk about F statistic later on. Right now, our objective is to look at coefficient of determination R squared, which is SSR divided by SST. It is the proportion of total error as measured by SST that is no longer error. So SSR has explained that amount of error that was originally present. So larger the value of R squared, the better it is. And since these are sums of squares, R squared value is anywhere between 0 and 1. Closer to 1, the better the fit is. If it is exactly equal to 1, that means all the points will fall exactly on the straight line. Now when you take a square root of coefficient determination, we get correlation coefficient. We talked about correlation coefficient earlier. A correlation coefficient is a measure of linear association between the two variables x and y. It is a value between -1 and +1. Negative values of R indicate inverse relationship between x and y, and positive values for R indicate positive relationship between x and y. A value close to either +1 or -1 indicates very strong correlation between the two variables. A value close to 0, either on the negative or the positive side, means the linear relationship is not present. So from R squared, to get R, we take a square root of r squared and you assign the sign of the slope. If the slope is negative, then you use negative of the square root of r squared. That will be our r. If the slope is positive, then you take the positive square root of r squared, and that will be our correlation coefficient. The next video will calculate all of this sums of squares and correlation coefficient and coefficient determination in Excel.